In this video, we're going to be going through Lewis structures of ionic compounds. The essential question that we're going to be answering in this video is how do atoms form ionic compounds through the transfer of electrons? So let's review quickly what an ionic compound is. So an ionic compound is a bond that occurs when you have a cation, which remember cations are positive, and an anion, which is negative. So opposites attract. And an important thing to remember about ionic compounds is the net charge. So when we add our cation and anion together, the net charge is always zero when you have an ionic compound. Okay? So metals, those have 1 to 3 valence electrons. They always lose all of their valence electrons. And in doing so, they are revealing a full outer shell below them. So let me show you what I mean. So I have this atom right here. Let me throw some electrons in this. So remember, our first energy level holds 2. The next one holds 8. And then let's throw 2 more on the outside. Okay, so this is a Bohr diagram for magnesium. So it has 2 valence electrons in the outer shell, one here, one here. So it has between 1 and 3 valence electrons. So when it forms an ion, it loses both of its valence electrons. So if I get rid of those, I'm going to lose the entire outer layer, and would you look at that? Now I have a completely full outer shell. So it now becomes just like a noble gas. It has a completely full outer shell. Now, nonmetals, so specifically anything with 5 to 7 valence electrons, those are going to gain to 8. So for example, if I had an atom where it had 6 valence electrons, so if I had 6 valence electrons, it needs 2 electrons to get to 8. So if I add those, I'm now going to have a -2 charge because I now have 2 more electrons than I started with. Okay, so that's essentially how ionic compounds form bonds. You have a positive cation, you have a negative anion, and they combine. And again, the big thing to remember is that we always have a net charge of 0. The cation and the anion will cancel each other out. Okay, so Lewis structures represent the arrangement of electrons in atoms or ions, showing how atoms are bonded together and the lone pair of electrons. So when we did this previously, we had an atom. So let's pick magnesium again. Magnesium has 2 valence electrons, so we're going to represent those with dots. That's it. That's how we drew Lewis structures previously. And now we're going to show how the electrons are transferred in an ionic bond. So here are the steps. Number 1, write the symbols. So we're going to do that just like we did previously. We're going to add a dot for every single valence electron. Then we're going to make sure that we are transferring from our cation to our anion. When a cation loses electrons, it ends up with a positive charge. When an anion is taking in electrons, it ends up with a negative charge. So we're going to do some examples and you'll see how these steps work. So let's start with sodium and chlorine. So sodium is Na, chlorine is Cl. So let's pull up our periodic table. Okay, so sodium is in group number 1, so it has 1 valence electron. Chlorine is in group number 7, it has 7 valence electrons. Okay, so sodium is going to end up with a +1 charge because it has 1 valence electron. Chlorine is going to have a -1 charge because it has 7 and it wants to get to 8. Okay, so those are the charges. And we know that they're going to combine 1-to-1 ratio because we have +1 and -1. Okay, so that's what we worked on previously. Now we're going to represent this with a Lewis structure. So let's begin by writing out our symbols. So we have sodium, and we have chlorine. Chlorine is going to get 7 dots. Sodium is going to get 1 dot, just like that. Now, sodium wants to lose the electrons, chlorine wants to gain them. So I'm going to draw an arrow showing how the electron is transferred from the sodium to the chlorine. That's it. Now, we're going to represent our ions by writing them out in brackets. Sodium is losing a valence electron, so it's not going to have any dots when I write out its ion. Chlorine is gaining an electron, so it's going to have all 8 dots. It now has a full octet. Sodium lost an electron, so its charge will be +1. Chlorine's charge is going to be -1 because it gained an electron. That's it. And again, when we combine these, we end up with the ionic compound NaCl. All right, let's look at another example. Okay, so we have calcium and chlorine. Let's look at our periodic table. So calcium is in group 2, and then chlorine is in group 7. So we've got calcium, it's in group 2, so it's going to have 2 valence electrons. Chlorine is going to have 7, just like before. Okay, so let's draw that arrow representing our electron from calcium being transferred to chlorine. Great. Now, if you notice, we have 1 valence electron here that is still hanging out. So we're going to need to draw in another chlorine, also with 7. And let's do the same thing. Let's take that other valence electron from calcium and let's transfer it to chlorine. There. Now calcium has given up all 2 valence electrons that it had, and then the 2 chlorines each took 1 valence electron from calcium. So let's write out our ions. So we have calcium. It lost 2 valence electrons, so its charge will be +2. And then we have 2 chlorines. Each chlorine has 7 valence electrons. It gained 1, so each one of those is going to have a -1 charge. Just like that. So if I wrote out our formula, it would be CaCl2. All right, let's do one more. Let's do one more that is a little trickier. So let's look at this one. So it says create a Lewis structure for the compound formed between aluminum and oxygen. So again, let's look at our periodic table. So aluminum is in group 3, so it's going to have 3 valence electrons. Oxygen is in group 6. To get to 8, it needs to gain 2 more electrons, so its charge will be -2. So we have aluminum. Aluminum's going to have 3 dots. And then we have oxygen. Oxygen has 6. So 1, 2, 3, 4, 5, 6. Just like that. Okay. So let's transfer some electrons. Well, oxygen needs 2, aluminum has 3, so let's transfer 2 from aluminum over to oxygen. Okay, great. Now that oxygen has all 8, but aluminum still has 1, so let's draw in another oxygen. So again, it's going to have 6. 1, 2, 3, 4, 5, 6. Okay, and let's transfer that other electron from aluminum. So it has now given up all of its valence electrons, but still have a problem because this oxygen has 1 that's still unpaired. So we're going to need another aluminum, and let's go ahead and take that aluminum on the left side, aluminum's valence electron on the left side, and let's give it to that oxygen. Okay, we're close. So everybody's happy now except for this aluminum down here. So we need 1 more oxygen. Let's fill that in. Okay, now this aluminum can fill in right here, and we're done. Okay, now this looks a little messy, so let's go one piece at a time. So we have, let's do our cations first. We had 2 aluminums. Okay, Now, you can put a coefficient in front to represent that I have 2 of those aluminums rather than writing out every single ion. Each aluminum gave up 3 valence electrons, so I'm going to write +3, and notice there are no dots, dots representing our valence electrons because it gave up all 3. And then we have 1, 2, 3 oxygens. Each oxygen gained 2, so they're going to have all 8 dots. Each one gained 2, so I'm going to put a -2 there. So our formula would be Al2O3. And that's it. So that's how to do Lewis structures for ionic compounds, showing the transfer of electrons from cation to anion.